Here I am again. This time we're going to be looking at the binomial theorem. Let's just jump right in. The binomial theorem gives us the ability to expand expressions of the form a plus x to the power n. And there are a couple of different cases you have to look at. The first case we look at is when n is a positive integer. N is a positive integer. Hold on a second. Right, that means you have something like a plus x to the power 5 or a plus x to the power 10, a whole number. As you're seeing from this expression here, binomial theorem can be written as a sum. A plus x to the n is equal to the sum from r equals 0 to n, then notice the lower limit is 0, of NCR times a to the n minus r times x to the r. By the way, that NCR term, some of you who have done statistics or any one of the other courses with me that would have required the use of that NCR bit. NCR simply means, I don't know where that went. Give me a second here. Yes, NCR simply means the number of ways of selecting R elements from n distinct elements. We're going to expand on that a lot more in the next tutorial. In fact, there's a whole section on combinations and factorial algebra that we'll be looking at. But this NCR, it's not a difficult idea. NCR, this means the number of ways of choosing or selecting R elements from n distinct elements. As an example, 10C3. That would be the number of ways of selecting 3 elements from 10 distinct elements. You can punch that up directly on your calculator. The NCR button on most calculators is over the number 5 key. So if I go, let me see, 10C3, I get 120. So there are 120 ways of selecting 3 elements from 10 distinct elements, right? So that's the meaning of that NCR bit. If you didn't know it before, well, at least you have a little introduction to it now. Okay, if we expand this sum, give me a second here. Yes, if we expand this sum, a plus x, that's that sum up there. Damn it. This sum up there. If we expand this sum, we get a plus x to the n, that's the left-hand side. And on the right-hand side, we're going to do the expansion. Starting with r equals 0, we'll get nc0 times a to the power n times x to the power 0. X to the power 0 is 1. Plus nc1 times a to the power n minus 1 times x to the 1 plus nc2 times, you get the pattern here, a to the n minus 2 times x squared. I'll do a couple more, plus nc3 a to the n minus 3 times x cubed. Plus ellipses, and I can write the general term. The general term is this term that's right inside the summation there. The general term is NCR times a to the n minus r times x to the r, and I can write the last term. There is a last term once it's a finite sum. If n is a positive integer, you're going to make it a finite sum. And you simply plug in r equal n. So you'll have NCN. NCN is 1. A to the n minus n, a to the 0, that's 1. And you'll end up with NCN times, and this is x to the n. A to the 0 is 1. Okay. So that's the expression written out in full. That general term is going to be very useful to us a little later on, this guy right there. Now, a slightly simpler expression is obtained when a is 1 to begin with. I usually like to use this other, you could always use this expression on top and simply plug in a equal 1 afterwards. But I like to use this simpler expression. I've been using it for a long time, so I like to continue to use it. Somebody's selling something. Anyway, a slightly simpler expression is obtained when a is 1. 1 plus x to the n instead of a plus x to the n. 1 plus x to the n. N still, by the way, being a positive integer. 1 plus x to the n is given by the sum from r equals 0 to n of NCR x to the r. And all you basically do, you would have basically put a equals 0. So this would have been a equal 1, sorry. This would have been NC0 plus NC1 times x plus NC2 times x squared plus NC3. NC3 times x cubed plus general term would be NCR x to the r plus, and then the last term would be x to the n. NCN x to the n. So I like to, when a is 1 to begin with, I like to go directly to this one. When a is 1, I like to go directly to this expression. When a is anything other than 1, then I go back to this one. Okay, the number of terms in the expansion is always n plus 1. So for example, if n is 6, you'll have 7 terms in that expansion. A plus x to the 6. If you expand out and get all the terms, you'll get 7 terms. And the next note there is, if n is a positive integer, the expansion is valid for all values of x that are real. The expansion is valid for all real values of x when n is a positive integer. That will not always be the true when we change n to not being a positive integer. Okay, in many cases, I'm continuing here, in many cases we do not need all the terms in the expansion. Sometimes we just need the first few terms in the expansion. All right, so I have several examples here. I'm going to go through most of them. And then I'm sure there's a worksheet under this, which I'll have you work on. So without further ado, let's jump right in. Part A. We want to basically you find a binomial expansion up to and including the term in x cubed in ascending powers of x. I'm sure I said that. Expanding to the following series in ascending powers of x up to and including the term in x cubed. So the first one, it was 1 plus 2x all to the power 7. That's what we're trying to expand. What I would do here is write out the generic expansion for a plus x to the n. So in general, not a plus x, 1 plus x, because this one started with a 1. In general, 1 plus x to the power n is equal to nc0 plus nc1x plus nc2x squared plus nc3x cubed. Notice they only asked me for the expansion up to and including determine x cubed. So that's why I stopped the expansion there. But specifically, I would like to expand 1 plus 2x to the power 7. So to expand this, if you compare the specific expression that you have to expand with the generic one, you see you start out with 1 in each bracket. X is replaced with 2x and n is replaced with 7. So replace x with 2x and n with 7. So let's see how that works out. One plus 2x all raised to the power 7 is equal to, remember now on the right hand side, remember I'm saying I'm replacing n with 7 and I'm replacing x with 2x. So everywhere I see n, I put 7. 7c0 plus 7c1 times, and x is being replaced with 2x times 2x plus 7c2 times 2x all squared plus 7c3 times 2x all cubed. And now I will simplify each term. 1 plus 2x to the power 7. 7c0 is 1. Anything c0 is 1. 7c1, I know that's 7. 7 twos, that would be 14x. 7c2, I don't know that offhand, so 7c2, that's 21. And 21 out of that bracket, the 2x all squared will give me 4x squared. So multiply that by 4 and I'll get 84. So the next term is plus 84x squared plus 7c3, don't know that either. That's 35. And out of that bracket of 2x all cubed, 2 cubed will give me 8. So times 8, 280 plus 280 x cubed. Y'all can check my arithmetic and algebra there, but I think this one is correct. So that's the expansion of 1 plus 2x to the power 7 up to and including determine x cubed. Like I said, in many cases and in many applications, you don't need all the terms in the expansion. Clearly, this would have had a total of 8 terms, but they only wanted the first 4, up to and including determine x cubed. There. So that's the first one. That's no big deal. Let's try the next one. Part B. That one is 1 minus x upon 2 to the power 20. 1 minus x upon 2 to the power 20. Again, this one starts with a 1, so I'm going to use, in general, I'm going to use general expansion for 1 plus x to the n. nc0 plus nc1x, nc2x squared, and nc3x cubed. To expand, 1 minus x upon 2 to the power 20. Compare the two terms. You clearly see the first term is 1 in each bracket. X is replaced by minus x upon 2, and n is replaced with 20. So replace x with minus x upon 2, and replace n with 20. So So let's do that on the right hand side. 1 minus x upon 2 to the power 20 is equal to NC0. N is 20, so that's 20C0 plus 20C1 times x upon 2 plus 20C2 times, that's not x upon 2, that should be minus x upon 2. 20C2 times minus x upon 2 all squared, and then plus 20C3 times minus x upon 2 all cubed. Again, I stopped there. Those were the instructions. 1 minus x upon 2 to the power 20 will give me 20C0, that's 1. 20C1 is 20. By minus x upon 2, that should give me minus 10x. 20C2, I have no idea, so I'll punch that in. 20C2, that's 190, times minus x upon 2 all squared would be x squared upon 4. So you always separate the numbers from the x, the coefficient. So this will be 190 upon 4. Can we break that down? 190 divided by 4 is 95 upon 2. So plus 95 upon 2x squared okay, and the last one will be 20C3. Well, this would end up being a minus, I'm pretty sure. 20C3 will give me 1140. And minus x upon 2 all cubed will be minus x cubed upon 8. So the minus comes out. And the 1140 upon 8 285 upon 2 x cubed. Again, please double check my arithmetic there. All right. All right, let's look at the next one. See what's in that one. I hope it's a one with a difference. If it's not, I'm going to leave it for you to do. Let's see what C looks like. C was 2. Oh, okay, that's one with a difference. 2 minus x to the power 9. 2 minus x all to the power 9. Now remember, the first term in there is not 1, so you got to use 1 plus x, a plus x to the n. A plus x to the power n is equal to, well, it was, let me see. Go back up there. NC0, a to the n, and then power of a goes down. Okay, so that's NC0, a to the n, plus NC1, a to the n minus 1x, plus NC2, a to the n minus 2, times x squared, plus NC3, a to the n minus 3, times x cubed. Okay. Now to expand, and this is the general expansion. To expand, 2 minus x to the power 9. There are 3 things you have to replace here. Replace a with 2. Replace x with minus x. And replace n with 9. Right? If in here I replace a with 2, x with minus x, and n with 9, I'll get the expansion. And same thing on the right hand side. I will get the expansion with 2 minus x to the power 9. So let's check it. 2 minus x all to the power 9 is equal to, excuse me, 9c0 times 2 to the 9th times 2 to the 9th plus 9c1 times 2 to the power 8 times minus x plus, oops, that should be 9, plus 9c2 times 2 to the 7th times minus x all squared, and then plus 9c3 times 2 to the power 6 times minus x to the power 3. And all I got to do is to simplify each term. 2 minus x to the power 9 is equal to 9c0 is 1, 2 to the power 9 is, I think, 512. Double check that. 9c1 is 9, 2 to the 8 is 256. 9 times 256. 2304. These are some big coefficients. So minus 2304 x 9c2 9 c2 times 2 to the 7, which is 128. It's 4608. So this would be plus 4608 x squared. And then the last one is 9c3. 2 to the power 6. 6 to 4. 9c3 is 84 times 2 to the 6 is 64. 5376, and the minus comes out from the minus x cubed. So minus 5376 x cubed. These are definitely not difficult to do. Let's see what D has to offer. Part D was, the product of two different brackets. But I want the entire thing up to and including the term in x cubed. 1 minus x times 1 plus 2x to the power 10. One minus x times 1 plus 2x to the power 10. Okay. Now, if you look at that expression, there are two sets of brackets, but only one bracket you need to use the binomial theorem to expand, the 1 plus 2x to the power 10. Whatever result you get from that expansion, you'll multiply that by the 1 minus x, and then expand that to get the overall expansion that they want up to x cubed. So we'll first expand 1 plus 2x to the power 10 using the binomial theorem. So we know that 1 plus x to the n, I'm using the expansion 1 plus x to the n, is nc0, nc1x, nc2x squared, nc3 x cubed. Notice I'm expanding that part all the way up to x cubed. You might say to yourself, well, why up to x cubed? Why don't we just expand it up to x squared? Because when we multiply by the first bracket, the x in the first bracket by x squared in the second bracket should give me x cubed. But wait a second. You'll see as we come down to the end why I did that. All right, what are we replacing? To expand 1 plus 2x all to the power 10, you have to replace n, or x with 2x, and replace n with 10. So let's do that. 1 plus 2x to the power 10. On the right hand side, I'm replacing n with 10 and x with 2x. That should give me 10c0 plus 10c1 times 2x plus 10c2 times 2x all squared, 10c3 times 2x all cubed. 1 plus 2x to the power 10 is 10c1, that's 1. 10c1 is 10, 10 by 2x is 20x. 10c2 I think is 45. Can I do something like this just now, 1 plus 2x? Yeah, but that was to the 7th, so you gotta be careful there. 1 plus 2x to the 10. Yes, 10c2 is 45, but you're multiplying that by 4. That's 180. So that's 180x squared. And then 10c3 is 120. Double check. And you're multiplying that by 8, coming from the 2x all cubed, times 8, 960. So plus 960 x cubed. So that's the expansion for the 1 plus 2x to the power 10 part. Now remember, overall, I want the expansion for 1 minus x. I can't write anymore to save my life. 1 minus x times 1 plus 2x to the power 10, which is the same as 1 minus x times the expansion that I got for 1 plus 2x to the power 10. So that will be 1 plus 20x plus 180 x squared plus 960 x cubed. Now, if we had only expanded this portion up to x squared, then yes, you're correct. The x by the x squared in the second bracket would have given me a term in x cubed. But remember, the 1 that's here by the x cubed will also give me an additional term in x cubed. So we wouldn't have quite gotten the correct expansion overall. So let's see. 1 minus x times 1 plus 2x to the power 10. What I'm going to do is get all the terms from this expansion, and anything that goes beyond x cubed, I'll just throw it away. Because the overall expansion is calling for the expansion up to and including the term in x cubed. You don't want anything above that. So let's see, I'll multiply 1 by everything first. I'll get 1 plus 20x plus 180x squared plus 960 x cubed. And then I'll multiply minus x by everything. Minus x by 1 gives me minus x. Minus x by 20x gives me minus 20x squared. Minus x by 180x squared gives me minus 180x cubed. And minus x by 960x cubed gives me minus 960x to the 4th, a term I do not need. So if you add up those two, you finally get an expression that says 1 minus x times 1 plus 2x to the power 10 is equal to, that should be 1 plus 19x. 180 minus 20, that's plus 160x squared. And 960 minus 180, I don't know. That should give me a grand total of 780 plus 780 x cubed. So that looks pretty decent. Okay, there's one more in that section up there, but I think I'll leave that one for you to do. Haha. 2 plus x to the 5 times, I'll leave a part of it for you to do. 2 plus x to the 5 and 1 minus x to the 10. Now this one is interesting. Get rid of this stupid line. From the perspective of, in the first bracket, I'm going to use the expansion for a plus x to the n to expand 2 plus x to the 5. In the second one, I'll use 1 plus x to the n. So let's see how this one goes. A plus x to the power n is equal to nc0 times a to the n, nc1 a to the n minus 1 x, nc2 a to the n minus 2 x squared, nc3 a to the n minus 3 x cubed. And I'm using that to expand 2 plus x to the 5 all the way up to determine x cubed. So for this one, I'll replace a with 2. I'll replace, well, x is the same x, a plus x and 2 plus x, so I don't have to replace x. X just goes back as x. And I replace n with 5. So therefore 2 plus x to the power 5 is equal to 5c0 times 2 to the power 5 plus 5c1 times 2 to the power 4 times x plus 5c2 times 2 to the power 3 x squared and 5c3 times 2 to the power 2 n minus 3 2 to the power 2 times x cubed plus yada yada yada. 1 plus, not 1 plus, what's wrong with you? 2 plus x all to the 5th power simplifies to 5c0 is 1. 2 2 4 2 0 2 16 32. 5c1 is 5. 2 to 4 is 16. 16 5 is 80. 5c2, don't know. 5c2 is 10. Oh, that's interesting. And then 2 to the 3, that's 8. 8 tens, that's 80 again. X squared. And then the last one is 5c3. I think that's 10 too, 5c3. Yeah, it is 10. Times 2 2 is 4. 10 4 is 40. X cubed. Good. That's the expansion of that part. Then the next part is I have to expand 1 minus x to the power 10. Well, I'll use 1 plus x to the n to expand that. 1 plus x to the power n is nc0, nc1x, NC2 x squared, NC3 x cubed. And I'm expanding 1 minus x to the power 10. To expand that, I need to replace n with 10 and x with minus x. So let's see how that goes. 1 minus x to the power 10 is 10c0, 10c1 times minus x, plus 10c2 times minus x all squared, 10c3 minus x all cubed. 1 minus x to the power 10 is therefore, that's 1. 10c1 is 10 by minus x minus 10x. 10c2 is 45. Forgot. It is 45. 10c2 is 45 by minus x all squared. That's x squared. So this is just plus 45x squared. 10c3, that's 120. And with a minus coming from the minus x all cubed, I'll get minus 120x cubed. So, how does the story start? So now I want the overall expansion for 2 plus x to the power 5 times 1 minus x to the power 10. That means I simply multiply each of the expansions by the other one. The first expansion by the second one. So the expansion for 2 plus x to the 5 up to determine x cubed plus 32 plus 80x plus 80x squared plus 40x cubed times the expansion for 1 minus x to the 10 is 1 minus 10x plus 45x squared minus 120x cubed. I'm going to leave that last part for you to do. Now remember, I want the overall expansion up to x cubed. So here's a good way to approach this. You kind of want to you can start with the 32 from the first bracket and multiply it by everything into the second bracket. So 32 by 1, 32 by minus 10x, 32 by 45x squared, 32 by minus 120x cubed. And you will keep all those terms. And then line them up. Next, you'll multiply the 80 by 80x, by everything in the other bracket. But notice, as soon as you multiply the 80x by the minus 120x cubed, you'll go past determine x cubed. So anything that goes beyond x cubed, just throw it away. You don't need to consider it. And then add them all up together. Okay, I'm leaving that for you to finish up. Not a lot. Come on. Stop protesting. All right, so that's that one. Now, they have some variations that they throw in here sometimes. So we're going to look at some of those variations. Find the term independent of x in the expansion of 2x squared minus 5x cubed. They're asking you for a single term, the term independent of x. Now, how are you going to get that? First of all, the power n is 10, so that means there will be 11 terms in this expansion. Don't assume that the first term is always the term independent of x. The term independent of x is usually the constant term. In almost all the expansions we did above, the term independent of x was the constant term. What we're going to do here is we're going to use the general term for a plus x to the n, and then plug in a specific value of r that would make all the x's disappear, and that will leave you with the term independent of x. Let me demonstrate. Let me make a little space here. Okay, now the general term, you generally speaking use it to find any particular term in the expansion. General term for the expansion of a plus x to the power n is NCR a to the n minus r and x to the r. So I'm going to write down the general term I'm going to try to derive the general term, GT general term, for 2x squared minus 5 upon x cubed all to the power 10. If you compare this with this, you're replacing a with 2x squared, you're replacing x with minus 5 upon x cubed, and you're replacing n with 10. So that's what I'm going to do in the general term. So replace a with 2x squared, replace x with minus 5 upon x cubed, and replace n with 10. And therefore, to get the general term for 2x squared minus 5 upon x cubed all to the power 10, I'll do exactly what I said with those replacements in here. So n is 10 CR, r remains as r. A is 2x squared, so that would be 2x squared raised to the power 10 minus r times, and x is replaced with minus 5 upon x cubed. Minus 5 upon x cubed all to the power of r. Okay, I can use a little bit of indices to simplify this. Use a little bit of indices to simplify this. 8 to 2. Yeah, I'm going to stop this one after this and start a new video after. Let's simplify. The general term is 10 CR times this is 2 to the power of 10 minus r times x to the power of, and then I multiply the powers there, that's 20 minus 2r, and then minus 5 to the power r divided by x to the power 3r. General term, simplifying a little bit more, that would be 10 CR times 2 to the power 10 minus r times minus 5 to the power r. And I'm going to try to merge the terms with x. I have x to the power 20 minus 2r on top and x to the power minus 3r on the bottom. Well, that simply means I subtract the powers. Remember your laws of indices? So this would be times x to the power 20 minus 5r. Let me write it a little clearer down here. 10 CR times minus 5 to the power r times x to the power 20 minus 5r. So that's the general term for this expansion. Now I can get any term out of that general term. If I want the first term, I plug in r equal 1. R equals 0. If I want the second term, I plug in r equal 1, and so on. I want to plug in a value of r that would give me the term independent of x. That means this portion with x must disappear. In other words, I want the power of x to be 0. So if that power 20 minus 5r is equal to 0, what does that make r? R will be equal to 4. And if r is 4, that will definitely give you the term independent of. So r equal 4 will give the term independent. We'll give the term independent of x. We'll give the term independent of x. All right. So let's do that. When r is equal to 4, the term independent of x is 10c4 times minus 5 to the power should not have been r, minus 5 to the power r. This should have been just r. Ugh. There, that's the general term. Yes, times minus 5 to the power 4. And if I put the 4 up there in the power for x, 20 minus 5 4 is 20 would give me x to the 0. So I end up with the term independent of x. That's 10c4 times minus 5 to the power 4. Let me see what that is. 10c4 is 210 minus 5 to the 4, that's 25 squared 625 times 625. Should get so that term is term independent of r is term independent of x is 131,250. That's a pretty decent way to get that. I want to stop this video here because I don't want each video to take, at most 45 minutes, and this one has already taken up pretty much that time. So I will stop this one here. Let me tidy this up a little bit, drag some stuff below, because I want to do it in the next video. This stuff here. Move this out of the way. I messed up. Put it back. I'm going to drag it below the worksheet. Oh man. What? You know what? Instead of doing that, I realize you wouldn't see the entire worksheet. Hold on. All right. All right. Here's the first worksheet. I'm gonna scroll so you can get an idea. You can stop the video whenever you need to, so you can get the entire worksheet. Worksheet number 1, based on what we've already done above there. The first problem there, by the way, is an extra problem that I found from for you to do proof by induction. So you can start with that. Everything else in this worksheet involves the binomial theorem. And stops at number 6. And I'm going to stop this video right here. So there.